You're live. So we're live. We're back to our random code, which is not as random today because we have been working on one problem. And that problem, well, it's the second problem. We solved one easy problem, and now we're working on a medium level problem. And I've already put some thought into the solution. Gave it some thought. I gave it some thought, and let me try to remember what it was. So, oh, stack. Okay, so we'll have a queue. Okay, the queue will store the roots. Okay, it will queue. The queue is implemented. By the way, it's time. We can continue the timer, but it's not that accurate, but more or less. Okay, so are we live? We're live. We're firing on all cylinders, or half of cylinders, I don't know. So we'll have a slice of 3 nodes. Okay. That will be our queue. And we need to return the root eventually. So the idea, we had an idea of going via the left tree and right tree, as a separate trees. But it doesn't change much because because we need to reverse all of them. All of the entire row we need to reverse. There was another problem where you could go like these two subtrees, along these two subtrees with 2 pointers, and it will be good, and it would solve it. In this case, I don't think it matters. And in this case, how many viewers we have? Nice little nice and no distraction. Yeah, that's the level of viewers, no distraction. 0 distraction, level of viewers, number of viewers, number of publicity. Okay, but we will also use a stack to reverse. Okay, but the stack will be a slice of integers, which are the values of those nodes. Okay, it's solved, and that's the solution basically. No? Yeah, let's see what else we need to do. So since this is breadth first search, and this is a queue, based on a queue, we'll have a loop, which will be working while length of queue is bigger than 0. That's the end of, okay. That will be the end of the queue. Well, that's where we exit, when we exit. But initially, we put in our queue what? We put the root. Yep. So we don't need to reverse the root. So we start with a root. And we want to go along. So this initial root is our initial list of, so we know that row length is this queue, length of queues. Okay, length of queue. We need to want to save it because that's how much we will go over. And then nested loop. Yeah, so we will go over each. And by the way, I can I? Yeah, I know how much time I have in the stream. So, let me do that thing and then I'll explain how it works. So for range row length, so we have, now we're looking at something on the queue. By the way, I'm not sure we can, so if queue is empty, we should also get out of that thing. So, but we should have the entire, so yeah, because that's how many we need to do. We will do them and we're out. Okay, so let's start doing them. Then we take from the queue value 0, which is the first value, because we put at the from the back of the queue and take from the front of the queue. Okay, so that thing is our now. Now is this. And what do we need to do with it? One thing we need to do is we need to read its value. Jeez, my Mac is warming up. Yeah, so the streaming is really taking some resources. Monitor, resource monitor. What is it? So CPU, yeah, what's taking power? Google Chrome, okay. So Google Chrome, high memory usage, 1 and 2, okay. So video streaming, okay, it's taking some memory. Renderer, okay, that's memory. What about power? Google Chrome, disk, network. Yeah, I mean, it's the first time it's getting this hot. It doesn't get hot usually. But with the streaming, yeah, it's putting some load on it. Yeah. So let me think. Okay, so the plan was to get the value of now, val. We need to put it onto the stack. Okay, stack is and stack and that value. Makes sense? Yes. Then some other things we need to do. We need to, but by the way, we only need to do that with the even ones. So with the odd level. So we will think how to track that. But for any level, what we need to do is to take now left, We need to queue them. Yeah, so we need to say that queue is queue and queue is append queue now left and right. Queue is append queue now right. So we took the next jobs, put them in the queue. The next we're queuing up the next level. Next level, we are in queue in the next level. We are in queue in next level. You know what my thinking is? Oh, that's what we put on the stack. Yeah. So that's also what we put on the stack. And only if the next level is odd. How do we count that? How many levels? There could be like 14. Well, we can, track levels. Levels start with 0. And at each row length, yeah, that's level 0. When we are done working, we say level plus plus. Now, if level, it starts with 0, so it's odd. If level modulus 2 is 1, then we need to do stack up. So that thing we need to do anyways. But then we need to stack up the... Oh no. Oh no, 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 no. So if it's odd, then we stack up the next. Stack up the now left. The values now right. Okay, so we stack them up. Else, so we stack them as we build the next. But when we go over, as we build the jobs of the odd row, so this row, but once we actually are on the odd row, we need to now, we need to take from the stack now. This machine is heating up. Gee whiz. Who would think? Who would think that you could heat up this streaming, could put some, I don't know, put some work on it. So it is putting some work. How much is this? 1 gig? Okay, we are streaming here. Huh? Okay. Well, it's not starting the fans, but it is heating up. Yeah, weird. Well, yeah. So now we want to pop from the stack. Now val. Okay. We say that now val is stack. By the way, when we read from the queue, we want the queue. We want to say that queue is now queue. Yeah. Now from the stack, which is last one, which is length of stack minus 1 usually. Offset, yeah, with the offset. Now, okay, we read, I don't know, we took that value from the top of the stack, retrieved it, and now we need to pop it. So we need to say that stack is stack length of stack minus 1. So that should be taken care of. Yeah, this updates the values of the row we are going at, of the odd row. If we are on the odd row, we're just taking stuff from the stack. If they are, and it's kind of important that this is a perfect binary tree. And we could be very close to a solution, actually. Do we need to do anything else? I'm trying to remember. So queued it up. We queued it. So here is our queue. Here is our stack. Here is our level 0. Levels change. So for as long while there is something on the queue, yeah, we remember what the length of the current queue is. So we need to go. That's the current level. Row length. That's the current row length, and for this length, we'll be reading from the queue. So now is the node, the now node. And so we enqueue its children from left to right. And if it's an even row or level, then we just took the values from its children, put them on the stack. And if it's an odd row, then we pop those values from the stack. We read them and pop them. Stack. And that means that but as because we will be going through the nodes from left to right, but the values on the stack will be put like this. It will be 3, 5, but from stack we'll take it from 3 to 5. Okay, start the opposite way. Yeah, the reverse. That's how we get the reverse. I think we can run it. I mean, it should be. Cannot use stack variable of type int. Is, wait a second, what's up here? Oh, that's, yeah, so stack, we need to, yeah, okay. That's a range. Nil pointer, where did we hit the nil pointer? Left value. What do you mean? Oops. So this adds things to the stack. It looks like the now is empty. empty. That's where we actually could get Neil. Oh, whoa. So okay, because there could be a situation when it's actually the last row. Like this row is even, but it has, yeah, let's say we are going over the last row of jobs. If there is no left, there is no right, then we don't need to do that at all. Yeah, because if it's the last row like this here, what will happen, there are 4 jobs on the queue. We're still in. So we know there is 4, so we're gonna take the one at the front of the queue. We'll try to append its left node, which is empty. So it should be appending Neil. So that appending Neil, I don't know what appending Neil does. Actually, sorry, appending Neil value. If you append a Neil value, what happens? What happens, playground, if we append a Neil value? For example, if we return append, we get some some slice with one value. Let's just do a test case and append a Neil value. Now we want slice of type struct, empty struct, and we append a Neil. What? Slice of type struct. So that slice can we run that? Syntax unexpected list. Struct is not an expression. Well, let's create a slice just for the test. I want to see what happens when you append a Neil value. I'm curious what happens. And to do that, I'm going to share this playground. Share this playground. I wonder what I'm actually sharing. Oh, I'm probably sharing just the window. Yeah, I'm pretty sure it's just that. Okay, so yeah, I'm sharing this. So I want to have I have some empty struct object. So there is a type, creating a type. Do I need to create a type? I need to create a slice. So I think I need that. So that's a slice value and argument to append. Nil as struct value. Yeah, so it says you can't use nil. But in this case, we might be. So you can't. Well, okay, we'll see. How about that? How about we'll see if it works, and then we'll get back to it. Yeah, let's do the main problem first. I like how I notice how much I get distracted and how many detours I take, like detour after detour. I don't know what's the nice word to say. I get distracted. Sidetracked. I sidetracked. So if that's fine, then we just need to check that there is now, if now left is not nil, if now left is not nil, then we need to do all of that. So if there is some, well, to be and now right is not nil, then we need to do that. I guess that's our what? Yeah. Invalid memory address. We pointer the reference. No. So all these values we append now left. So what it says, it can't, but now is empty. Now is empty. How can now be empty? When we're done with row length, which had actual values. So that's what I'm saying. It appended nil values. It appended a bunch of nil values. So I guess we need to do that as well. Yes, but so we don't want to append the nil values at all. So it works, but so it worked here. That's good news. It didn't work here. Why not? No, I was looking like, why is the shorter test case? Why might it not work? So it didn't reverse anything. So our reversal happens. Okay, I see. So it looks like, because this is the reverse. This is the reading of the values. Here is the reading. And this is the writing. And that writing needs to happen even if it's the last row. That's the thing. So reading, we don't want to append more jobs that are empty. But we do want to read them if level 2 is 1, if it's an odd level, then we do need to write them still. Yay! Yay, 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 yay! So, yay or nay? Well, the tests, the initial tests, we passed successfully the initial tests. Let's do the full tests. Yeah, I think it should be working. Yay, it worked. Solved. Take. Well, it says about an hour, maybe 40 minutes. I don't know. Clean time. 40 minutes, but we solved it in an hour. That's not bad. Not bad. That's not bad. Not bad. Well, what can we say? We have like, I don't know, a couple of more minutes. This is the perfect solution. You can't do it any better. It doesn't get any better than that. But I think, yeah, so let's quickly go over it. We have a queue, we have a stack. The queue is for the nodes, to queue up those nodes row by row. Because as we read the row, we queue up its children for the next job. By the way, I mean, then yeah, we have a stack of values which will reverse out those values, and we'll read them in a reverse order that way. So we track the level for there is something on the queue. By the way, there is a test case of, is there an empty? There is a case with one node. We'll just return one node. Yeah. So row length is that is where we remember, where the this algorithm remembers how long is this current row we are going to do. And and okay, so and for that length, for range of row length, this many times we are going to go over over the queue. We take the first, we dequeue the first element from the front of the queue, and we remove that element. Then we check that there are some children if there are children, that element has children, we in-queue them left and right, and we stack up their values because that's the values. But we do that if that's an even row. When we go through the even row, we stack up the children of that row because that will be the odd row. By the way, I just thought of this thing, because if the stack is empty, no, the stack is empty only in the beginning. I thought we to get rid of the level, but no, I don't think we can get rid of the level. Because if we just look at when the stack is empty or not, it's empty at the end, like the very end before we put something on it. And then once we put something that's here is where we put values on the stack, push values on the stack. And yeah, it has something at that moment, yeah. So, and yeah, but if if the level is odd, yeah, we read from the stack, which gives us those values in reverse order, and we update the values in the tree, in our tree. Yeah, the node values in our tree, because now is the pointer to that node, to the current node. And that's, yeah, so we increment levels, and that's kind of it. 36 minutes, medium level problem, binary tree, binary tree solved. Thank you for watching. Like and subscribe, and we'll see you in the next video.